Hey guys, so I was asked to do a few more examples, so I've got 4 of them here for you guys to look at. Now, I wrote these problems a while ago, so I actually don't even remember what the zeros are off the top of my head, so I'm going to be approaching it from about the same place that you would be, okay? Remember the last number here, that's the top, so 1, 5, and 25 are the possible top numbers, and 1 is the only possible bottom number there. Okay, so let's start with 1. Okay, that's a nice one to start with. I always recommend, I think I've said it a bunch of times, to start with either +1 or -1. All right, bring it down, multiply, add, multiply, add, and you know what? I don't think that's going to get us anywhere because this is not going to be anything close to 60. So let's just do it again. 1, -8, 4, 60, -25. And we'll try -1 this time. Okay, multiply, add, multiply, add, multiply, and 60 minus 13, that ends up being 47. You know what? That doesn't really seem to work either. Okay, then let's move on from there. I'm going to erase this time, simply because I don't know how much space this is going to end up taking up. All right, let's try, well, since I know I made these appropriate for the graph when it gets made, let's try 5 and see what happens there. Okay, to have the numbers written right, 1, -8, 4, 60, -25. Yep, looks good. So let's see, bring down the 1, multiply, add, multiply, add. Oh, here we go. Multiply, add, and multiply. Okay, so we found one of our roots. It looks like 5 is going to be one of them. That would be a dot right here, okay, at x equals 5. Now I'm kind of curious what the other ones are going to be. We still have 3 more that we need to find. So let's see if we can guess our way through those. Well, we already know 1 and -1 aren't going to work, so why don't we... Well, 5 worked once. Try it again. Bring down, multiply, add, multiply, add, multiply, add. Okay, so it looks like 5 has a multiplicity of 2. Okay, so that's going to show up twice. Now, this one right here, this would be x squared plus 2x minus 1. We already know 1 isn't going to work and -1 isn't going to work. And at this point, well, since this is a 1 now, that we've basically exhausted all the 5s. So I'm thinking it's going to be either something that's irrational or possibly even imaginary. I don't know. So we'll just use quadratic formula on this one here. Actually, no. Why don't we do completing the square since we can. This is an even number and it's a monic, so we can go ahead and do that. We're going to make this, let's see, x squared plus 2x equals 1, plus box, x plus half of 2 is 1. 1 squared is 1. And 1 plus 1 is 2. Okay, yeah, that would explain why we were having some issue there getting one of the other numbers, because square root of 2 is totally not going to be one that works out nicely for us. We will square root both sides. That leaves us with x plus 1 is the positive and negative square roots of 2. Subtract 1 from both sides. Now I'm going to go ahead and write it separately. So it's going to be negative 1 plus the square root of 2 and negative 1 minus the square root of 2. Now while those are exactly the roots, they're not exactly helpful for us right now. So go ahead, type it into your calculator. This one right here, it's going to be about let's see what it says, I'll say 414, okay? Basically, it's almost 1/2. So I would put that dot right about here. Okay, I'm just kind of ballparking it here. Graphing is not meant to be super precise anyway. And this one, put that in the calculator, and I've got negative 2.4 roundabouts. So that's going to be about here. Okay. Well, we've got 4 roots accounted for. This happened once, this happened once, this happened twice. All righty. We know that right here, that number is our y-intercept, 25. That would be, well, here's 20. That'd be 30, 40. 25 would be right here. It's even, and it is positive. Okay, so we're going to have arrows pointing up and up. Don't know why I made that the letter A. There we go. All right, let's just see what it says to do. So we're going to go ahead and go down, 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 and we're going to hit this 0, this root right here. It had a multiplicity of 1, so we'll just keep on going. And we'll just curve around till we get to our y-intercept. This is a good time to go ahead and turn back. And now we're at this 0, at this root. And it's odd again. It's 1. So we'll just go ahead and go through it. It doesn't really matter where you turn. I mean, we could turn it here. We could keep going all the way up to here, maybe even, and turn it. Point is, we do need to come back to 5. Now that is a multiplicity of 2. There's 2 5s. That's even. So we are going to bounce and go right back up. So you end up with something that looks basically like that. Okay, the graphs that we're making here, they're not going to be exactly what the actual graph is supposed to be. I'll show you the real graph for this when we're done. But the important thing is that we have the end behavior, both arrows are pointing up. We have 3 distinct zeros plotted on the coordinate plane, one of them exactly, 2 of them are approximate. And at each of those zeros, the graph is doing the appropriate behavior, whether it's to go through or to bounce or touch. Okay, great. So we've done one of them. Let's do another one. This one, there's a number in front. Now what that tells me is that one of, or at least one of the roots is going to be a fraction. Now, if you're not a fan of dealing with those when it comes to finding roots, well, if there's only one, we can get there fairly smoothly. Keep in mind, let's see, 1, that's our only top number possibility, and the bottoms are 1 and 5. So the only fraction it could be would be, 1/5 or negative 1/5. And again, I don't remember this one at all, so let's just start with 1 again. See what happens. That's going to be 5. Add those together. We've got negative 4. Multiply those. We've got negative 4 again. Add them together and multiply. Hey, look at that. We have found one of them. 1 is definitely one of our roots. Okay, so now we need to come up with a number to use next. We can do 1 again, or we could try -1. Well, let's try -1, see what happens. I am not feeling this one. Yeah, no, that is definitely not going to be a 0. So let's try it again. Let's use +1 again. So this would be the second time. That's 1 time. Bring down the 5, multiply, add, multiply, add. Oh, great. So 1 is definitely going to be one of our roots. It's going to show up twice. Okay. And here, well, you've got a choice. Okay. We know you could try 1 again. It's not going to work. At that point, we can start looking at using 1/5. You can rewrite this as 5x plus 1 equals 0 and solve that, subtract 1 from both sides, and then divide both sides by 5. Or if you just want to keep going with synthetic division, you can. When you multiply those together, you do end up with 0 again. So the last one's going to be -1/5. And -1/5, well, that's less than half. So it's not going to be here, but maybe like, I don't know, there or so. Again, it's just approximating for something like that. 1/5 is kind of hard to really spot exactly on this coordinate plane. And our y-intercept is 1. Okay, that is positive. That is odd, which means we're going to have a arrow over here and an arrow down here. Down to the left, up to the right. And let's go ahead and graph it. Here we go, drawing a line. We hit this 0. It has a multiplicity of 1. Let me actually write that down. Multiplicity 1, which is odd. So we'll go ahead and go through all the way up to the y-intercept of 1. And then we'll go ahead and curve back around. And now we're at 1, which we already said has a multiplicity of 2. 2 is an even number. So we'll go ahead and reverse course. Boom, boom. And now we're going back up again, and it takes us right to that other arrow that we were hoping for. So there we go. Now again, this is a caricature basically of what the graph is supposed to look like. We'll take a look later at what the real graph is, and we can compare, see how we did. But the important features are that we've got these 3 points plotted. The graph goes through here, it bounces here, and the arrows are pointing the correct directions. All right. This is a very zoomed in graph. And we don't have a lot of choices either. It's going to be 1 or 1 and 2. Positive, negative, of course. I don't know what we should go with. We've been doing +1 every single time. Let's do -1 this time. Watch it not work. But let's see. That's going to be -2. Add. Multiply. Add. Multiply. Add. And multiply and add. Hey, great. It worked out. So that's one of them. We have x equals, where am I going to put it? I'll put it over here. X equals 1. Alrighty. Let's use -1 again. It worked once, maybe it'll work twice. Multiply. Add. Multiply. Nothing there. Add. Multiply. Yeah, that's not going to work out. 2 minus 1. So let's switch it to +1. Maybe that will work out for us. So there's, break down the 2, multiply, add, multiply, add, multiply, add. Well, there we go. So now we have x equals positive 1 as one of our roots. And, well, we know negative 1's not going to work anymore, but we haven't said anything about 1 working twice, so let's just see what happens. Bring down the 2. Okay, that's going to be 1 times 2, which is 2, and that's 5. We are nowhere near what we need to make this happen. So the only thing left to go with, guys, since this is a quadratic at this point, this is 2x squared plus 3x plus 1. The only thing to do is go ahead and use a fraction. If we end up with a bunch of weirdness going on down here, right away we'll know that it is not working out. But we'll bring down the 2, multiply, and, well, 1/2 times 2, that's 1. So that's 4, multiply, and that's 2. So nothing ugly, but also not correct. So let's try negative 1/2. Bring down the 2, multiply, add, multiply. Oh, great. Well, there we go. So at this point, well, you know, I don't know why I was saying that negative 1 wouldn't end up working, because I think based on this, because this right here is 2x plus 2, and we can be fairly safe in saying that negative 1 is going to be the answer to that. So bring down the 2. Wait, no. Yeah, that's right. Negative 2 and 0. There we go. So negative 1 has a multiplicity of 2, and both of those guys have multiplicities of 1. So we'll go with dot here at 1. This one has an odd multiplicity. Here's negative 1. This is the one with an even multiplicity. And then negative 1/2, which is, fortunately, this is zoomed in enough, so it's going to be right there. This is even, and it's positive. So our arrows are going to be here and here. And that is our y-intercept. So we'll go ahead and just put that down. All right, here we go. This is the even one. That's the one where it's going to bounce. So we'll go ahead and approach that. When we get to that one, we're going to curve back. It doesn't matter. We can go all the way up here. We can just go this far. It doesn't matter. Again, because this is just a caricature of what the real graph looks like. We're just trying to get down the important features. Okay. And there we go. I get a graph looking something like that. All right. Arrows are pointing the right direction. We have the correct dots plotted. And it looks like we have the graph doing the right thing at each spot. All right, last one here, guys. This time we've got 1, negative 1, negative 11, and positive 11. All right. Again, our choices are 1 and 11, and on the bottom is going to be 1. Let's go ahead and use positive 1 this time just to start it off. Those are going to cancel out. That's still 0. That's negative 11. That's negative 11. And that is 0. And you know what? Hold on a second. This right here is x squared plus 0x minus 11. In other words, that's x squared minus 11 equals 0. We can tell right off the bat here that is not going to be a friendly rational number here. Okay, add 11 to both sides, square root both sides of the equation, and we have simply that x equals, that looks absolutely terrible, let me do that again, x equals positive and negative square root of 11. So every single one of the roots, okay, x equals negative square root 11, x equals positive square root 11, and x equals 1. They all happen exactly one time. Okay, now you can just type in your calculator to see what these numbers are. They're going to be about 3.3 and negative 3.3. Okay. 11 is our y-intercept. This is counting by twos. 2, 4, 6, 8, 10, 11 would be right here. And then we'll go ahead and put points at x equals 1. At 3.3, which let's put it right there, and negative 3.3, we'll put it right about there. It's positive and odd, which means an arrow goes up on the right and down on the left. And we're going to go through every dot. None of them have an even multiplicity. So we'll just go up through there. Got to hit that y-intercept, come down. Almost missed it. There we go. And come back around. Almost missed that as well. And there we go. That's that one graphed as well for us. Now on the next bit here, I have the actual graphs. So this is the actual graph for number 1. Let's compare that to what we did. Here's what we got. Okay, arrows are both pointing up, and we've got those 3 dots here. Here, arrows are both pointing up, and we've got 3 dots in the same place. This is that middle place, kind of hard to tell, and then we bounced at 5. Here's this one. We have a dot here. I think I remember that being about 1/5, negative 1/5, and that being 1, where it had a multiplicity of 2. It's odd and has a positive leading coefficient. That's what it's supposed to be. That's what we got. I'd say that's pretty close. Number 3, here's this one. Now, I think we kind of overshot this part a little bit, but it really doesn't matter. Here's negative 1. Here's that negative 1/2. And you see a little bit there how it does kind of lip over the top there a bit. And then your final dot there. And then the last one should look like this. Okay, so there's the 11. Here's the 3.3, the negative 3.3. Here's 1. We went through all of them. It's positive and an odd degreed polynomial. So hopefully that was helpful for you guys. That's 4 more polynomial equations graphed. If you've got any more questions, I'll be happy to answer those offline. Thanks.